Math 110, System of Equations in 3 Variables, Sections 6.2. Now, a linear equation in 3 variables is the equation equivalent to one of the forms ax plus by plus c, z equals d, where a, b, c, and d are real numbers and none are 0. Now, a solution of a system of the 3 equations in 3 variables is an ordered triple that makes all 3 equations true. Now, we're going to be kind of seeing these types of processes embedded into us trying to solve them, and it's Gaussian elimination. We're going to be able to interchange any 2 equations, meaning I can take 2 equations and group them together. I can multiply both sides of one equation by a non-zero constant, and I can add any non-zero multiple of one equation to another. So solving this first one in 3 variables, here's kind of a set of steps of what I'm going to do. The first step is I'm going to pair one equation with the other 2 to eliminate a variable, and I want to eliminate the same variable in both. So in this case, I can pair equations 1 and 2 together and 1 and 3 together. So this is equation 1 and 2. This is equations 1 and 3. So now what I want to do is, now that I've paired these 2 equations together, I want to be able to eliminate a variable. In this case, I want to eliminate z. Z is really easy to eliminate here, and I can eliminate z in this one. In this case, canceling it out, I get 5x equals 15. For this one right here, I would have to use number 2, the rule number 2 for the Gaussian elimination. I can multiply any equation by a constant that's non-zero, so in this case it's 3. So distributing that 3 through, I get 3 times 3x is 9x, 3 times 3y is 9y, 3 times negative z is negative 3z, and 3 times 4 is 12. And so now I can add those 2 equations together, and so I'm going to get 10x plus 7y equals 23. So now step 2, I'm going to pair the 2 new equations together and try and eliminate another variable. Well, in doing so, my x is already by itself here. There's no y there. Technically the y variable is already eliminated here because it got eliminated here. So that's done. Solving for this variable though, because I have to know what x is, divide both sides by 5 and I get x equals 3. Then I have to take this 3 and I have to plug it back in. And so I'm going to get 10 times 3 plus 7y equals 23. Minus both sides by negative 30, divide both sides by 7, you're going to get y equals negative 1. And so now I have to take both of these, right? We're working backwards here, and I got to plug them all the way back into one of the originals. I decided to do this equation here. So I got 3 times 3 plus 3 times negative 1 minus c equals 4. Simplify, that turns into 6. Minus 6 on both sides, I get negative 2. Divide both sides by a negative, I get z equals 2. And so the solution is going to be the ordered pair where x is 3, y is negative 1, and z is 2. So a quick review on that. The first step that I did is I paired one equation, which is equation 1, with the other 2, equation 2 and equation 3. So that's why I had equation 1 and 2, equation 1 and 3. And I eliminated the same variable in both equations. I eliminated z at least. And I multiplied this one by 3 so I can eliminate z. Then step 2, I paired the 2 new equations together, this equation and this equation together, to eliminate another variable. And so it just so happened that that same variable was already eliminated, which was y, so I could just use this one to solve. Divide both sides by 5 and I got x equals 3. Plug it back in. Step 3, got to plug back in working backwards, so plugging it back in, 10 times 3, and then solving for y, I got y equals negative 1. Then I have to take both of those values and I plugged it into this third equation here, even though you can plug it into either of them, it doesn't matter. And so I plugged it back in, and that's how I got z equals 2, and so I wrote the answer as a point. Example number 2, in solving this system, first step, I need to pair one equation with the other 2 to eliminate a variable. So in this case, it looks like I can pair equations 1 and 2 and 1 and 3 together again. And so I want to eliminate the y. And so this one was really easy. It just cancels out this one. I'm going to have to multiply this top equation by 2. And so I can eliminate y there, adding straight down. That's how I get all those other values. Step 2 is I need to pair the two new equations and eliminate another variable. So pairing my two new equations together, I guess I can eliminate the x here. So I multiply the entire equation by -3. And so that's how I got the -6x here, and then there's a positive 6x there. So adding those two equations together, I get -3z equals 0. Divide both sides by -3, and I got z equals 0. So now step 3, plug back in working backwards. So I have to take this z equals 0 and plug it into one of these equations. And I plugged it into this one. Solving for x, because this is 6x plus 0 equals 6. Divide both sides by 6, I get x equals 1. So then I have to take both of those values and I have to plug them back into one of the originals. And so solving for y, that turns into 4, that just disappears. Subtract both sides by 4, divide both sides by 2. I got y equals 2. And so writing my answer, it's going to be 1 for x, 2 for y, and 0 for z. Now we're going to look at a word problem here. And so just so something that we can verify, I have the answer listed down here at the bottom. It says Luis inherited $15,000 and invested part of it in a money market account, part in a municipal bond, and part in a mutual fund. After 1 year, he received a total of $730 in simple interest from the 3 investments. The money market account paid 4% annually, the bonds paid 5% annually, and the mutual fund paid 6% annually. There was $2,000 more invested in the mutual fund than in bonds. Find the amount that Luis invested in each category. Now that's a lot of information straight in one problem. And so what we have to do is we have to start taking this information, contextually putting it together, and start trying to create some equations here. So just to make it easy, I'm going to let x be the money market, y be the bonds, and z be the mutual fund, just so I don't have to sit there and write all that out. So the different equations that we're going to be able to create, the first, this information here, it says 15,000 is invested part in money market, municipal bonds, and mutual fund, which means that x plus y plus z equals 15,000. Each of these, if you add it all together, you get 15,000. Now the next, it says that he received a total of $730 in interest from each of those accounts. So the money market was 4%, the bonds was 5%, and the mutual fund was 6%. So I'm going to get 0.04 times whatever it was in the money market, 0.05 times whatever it was in the bonds, and 0.06 times whatever it was in the mutual fund. And that totaled $730. Then the last equation, it says there was $2,000 more invested in the mutual fund than in the bonds. So I would write it like this: z equals 2,000 plus y. Because z, representing my mutual fund, there's $2,000 more in that mutual fund than it is in the bonds. So that 2,000 added to whatever the bonds is going to be my mutual fund. And so from here, this is, you're going to have to use the process to be able to solve it. You would have to plug in z into both of these. So you'd take the z, you'd plug it into there, you'd take the z, you'd plug it into there. Then you would be able to, because this is substitution, then you'd be able to create a system of 2 equations, and you'd be able to solve it from there. If you have any other questions, please leave them in the